Hi, welcome to another exciting edition of CG Shader Development for ScreenSpace Shaders. My name is Nate Nestler, and this is for Hyperactive Studios. Okay, so basically, we left off previously with our good old ScreenSpace skybox, and this is based off of that one. So you're going to copy and paste your ScreenSpace skybox from the previous video, and then you're going to do this one. This is going to be a pass-through. So pass through. So that way it looks like, it looks like the, well, I'll show you. You're going to apply this directly to the object, so it looks like this. So basically, you're seeing an image where the model would be. And this is pretty cool. Extremely useful for certain circumstances. I don't know, it's pretty neat. You can see people hanging out over there and whatnot. But, cool as it is, let's look at how to make it now. So, how do we do this? Alright, so there's going to be some changes here. We're going to go into our float script here, standards global here. Open lesson sign here, string UI widget equals, in quotes here, none, close quotes, semicolon, so that's all the same. Next part isn't though. String here, and there's going to be script class equals, in quotes, object, close quotes. Now this is no longer scene, this is object, okay? Okay, so then we're going to go string here, script order equals, in quotes, standard, close quotes, semicolon. This is standard instead of pre-process. Okay, so that's totally different because we're doing an object, which is standard rendering mode. Okay, and this is for NVIDIA's FX Composer only. So you probably wouldn't do this for another program unless they built their paradigm right around this one. It can vary between programs, what you have to do, or if you're writing your own, depending on what you want to implement and how you want to handle stuff. So, you know, but for this program, this is what we have to do in order to try out these techniques. So string here, space script output equals, in quotes, color, close quotes, semicolon. And then string script here equals, in quotes, technique equals technique, 0, semicolon, colon, semicolon, quotes, semicolon. And again, this is our color we're going to output. And this is standard, semicolon at the end, because remember this is all one line here inside of this. Oh, sorry, no, it's semicolon at the end of each one of these. My mistake. There's a semicolon in there too, though. Close greater than equals 0.8 semicolon here, and then here comes our matrices. I probably have one extra one here. I can't remember. I did a number of things trying out in order to make this work, so I may have one left over I don't need. I didn't really go back and check real close. Float 4x4 here, worldview PROJ colon worldview projection. Open less than sign here, string UI widget equals, quotes, none, close quotes, semicolon here, closing greater than symbol, semicolon, float 4x4, view here IXF here, colon, view inverse, open less than sign, string UI widget equals, in quotes, none, close quotes, semicolon, open greater than sign, semicolon, float 4x4 here, world XF here, colon, world, open less than sign, string UI widget equals, in quotes, none, close quotes, semicolon, close greater than sign, semicolon, then float 4x4 world view IXF colon world view inverse here, open less than symbol here, string UI widget equals, in quotes, none, close quotes, semicolon, open closing greater than symbol, semicolon. Okay, so that takes care of our matrices. For like I said, I probably have some extra ones in here that I really didn't need, so probably no more than one or two, but regardless. Float background depth here, it's greater than string UI widget equals, in quotes, none, close quotes, semicolon, close greater than symbol equal 1.0 semicolon. Okay, so this gives our depth background, which is 1.0 as always. And then we're going to do our skybox texture. It's the same as before, should be identical, shouldn't see anything different here. So this is all the same. And we just have texture, skybox texture here, open lesson symbol, string, resource name equals, in quotes, default underscore reflection dot DDS, close quotes, semicolon, UI name equals skybox texture, here, in quotes, semicolon, and then string resource type equals, in quotes, cube, close quotes, semicolon, close greater than symbol, semicolon, sampler cube, skybox sampler equals sampler state, open curly brace here, texture equals open greater than symbol, skybox texture, close less than symbol, open less than symbol, close greater than symbol, semicolon, min filter equals linear, map linear, semicolon, mag filter equals linear, semicolon, wrap S equals clamp to edge, semicolon, wrap T equals clamp to edge, semicolon, wrap R equals clamp to edge, semicolon, close curly brace, semicolon, and then we're going to move on down to the next. There's our structs here. And they're going to be the same as before. This is why we copied the last one, because it's a close match to it. Because we are using that cube map skybox basically in order to do our pass-through for our image. So that's what's getting seen through the model based on its view. That's why we had the view in there for the matrix there. Anyways, struct VSN here, open curly brace here, float 3 position, colon, position, semicolon, float 3 here, UVW, colon, text chord 0, semicolon, close curly brace, semicolon. Now this should be the same as before. You shouldn't have any changes here. Struct VS out, open curly brace here, float 4, position, colon, position, semicolon, float 3, UVW, colon, text chord 0, semicolon, close curly brace, semicolon, struct FS out, open curly brace, float 4, color, space, colon, color, semicolon, close curly brace, semicolon, and then VS out here, main VS, open parentheses, VS in, space, IN, close parentheses, open curly brace, VS out, space, out, semicolon, out dot position equals mul, open parentheses here, world view projection, comma, float 4, open parentheses, IN dot position dot XYZ, comma, 1, close parentheses, semicolon, out dot UVW equals mul here, open parentheses, world XF, comma, float 4, open parentheses, IN dot position dot XYZ, comma, 1, close parentheses, minus float 4 here, open parentheses, and okay, so yeah, we're just doing our object position based on our world view projection matrix. So we're multiplying that times our position, standards, things. Here we get back our position, and now let's worry about, I don't need this anymore. Gosh, I had leftovers in there. Out.uvw equals mul here, open parentheses, world xf, comma, float 4, open parentheses, in dot position dot xyz, comma, 1, close parentheses here, and close parentheses here. For multiplying that is our world matrix here, minus our float 4 here. And this is dealing with our view. We're going to subtract it from our view matrix. So again, this is going to be our translate here, because this is going across our W. I've already shown this umpteen times, so I'm not going to do it again. View IXF here, 0 is going to be our X for our dot W here. View IXF 1 here, dot W is going to be our Y, and then view IXF 2 is going to be our Z here, dot W, 0, semicolon. Alrighty. Return out. Great. FS out, main PS here, open parentheses, VS out, IN, close parentheses, open curly brace here, FS out, out, semicolon, out dot color equals text cube, open parentheses, skybox sampler, comma, IN dot UVW, close parentheses, semicolon. Okay, so what's going on here? We are getting the pixel from our texture cube. So it's identical as before. So yeah. And the key difference with this one is it has to do with the view. I'm sorry, I was trying different things earlier to make it work, but that's all you need is this here for getting your UV lookup. UVW lookup anyways. And we're just doing our world position coordinates here with our subtracted from our view angle in order to get our directional vector to look up our pixel. We turn out with our pixel, so now we got our pixel that we're looking for on this thing for the pass-through, and it's going through the model now based on the angle here from the vector coming off of the actual vertice. So going back from that angle, we look up our pixel accordingly, and technique is technique 0 here, open less than sign here, string script equals in quotes pass equals PO semicolon close quotes semicolon close greater than symbol curly brace pass P0 open less than symbol string script equals in quotes draw equals geometry not depth, not buffer, not the draw buffer. We are going to not equals to buffer. We're going straight for geometry rendering here and not into the actual rendering buffer. Semicolon here, quotes, semicolon, close greater than sign here, open curly brace, def test enable equals true, semicolon, def mask equals true, semicolon, blend enable equals false, semicolon, cull face enabled equals false, semicolon, def func equals L equal, semicolon, vertex program equals compile VP40 main VS, open close parentheses, semicolon, fragment program equals compile FP40 main PS, open close parentheses, semicolon, close curly brace, and there we go. And so this should all be pretty straightforward. Maybe it'll actually go down to, let me check real quick. I think we might be able to go down to ARB VP1. Let's see. Maybe not. We'll find out, right? ARB FP1. I can't remember if you can. And yes. Yes, you can get away with it. There we go. That solves that. So very cool. Yes, and you might as well take it down to ARB VP1 and ARB FP1 because you don't need to have it any higher than that. I thought it'd go back that far in the processing, and it sure does. So it'll run on super old hardware. This technique will, which is really nice indeed. Okay, so with that, that is our screen space pass-through. Okay, I'm going to middle click in here. I'm going to hit Control Z to undo that and take it off of there, off of the good old teapot there. Okay, next one I want to do is going to be, oh no, not God Rays yet, although that'd be nice, but no. We are going to do radial blur though. So we're going to do another one here for radial blur. Now let's have a look at what that looks like. It just keeps wanting to go back to -1 for whatever reason. There we go. So we have a radial blur happening there. So screen space through here. Okay. So with that, let's see what we have here. So we have screen space radial blur, and description of your shader goes here. Yeah, I came with that earlier. License, blah blah blah. Okay, so this is all the same. I guess copy and paste the previous one. We're going to be writing this one a good bit different than the others. So because this is a post process, so this one is different than what we've previously been doing. Okay, so now we're going to go over our post process here. So we're going to do float script here colon standards global. Open less than sign string UI widget equals in quotes none close quotes semicolon string script class equals in quotes scene close quotes semicolon string script order equals in quotes post process close quotes semicolon string script output equals in quotes color close quotes semicolon string script equals in quotes technique equals technique 0 semicolon close quotes semicolon close well, it'd be greater than sign, equals 0.8 semicolon. Okay. From there we have number of samples. Alright, so we have define here num underscore samples and then space 32. Alrighty. And then now we're going to go here and do our artistic controls. So, very simple. We have float here, space blur, amount, and then open less than sign here, and then we have string here UI name equals in quotes blur amount in quotes semicolon. I really need to copy and paste this artist controls to the other ones. Totally forgot to do that. Oh well, I did this originally and then forgot to paste it to the other ones. Oh. we're going to do a samples. Now you can actually change the number of samples that you want. 16 is typical for a game engine. You can go as low as 10. But it depends on what you can do for processing, for how much you can handle on the engine. You could also set this up to where this could be a control that is used for your screen space sampling, for how many samples you do in your screen space for different ones. Maybe if you're radial blur, you allow for people to, turn up radial blur to be higher quality or whatever for performance attributes in the game. It's up to you what you want to do. But anyways, string UI name equals, in quotes, blur amount, close quotes, semicolon. String UI widget equals, in quotes, slider, close quotes, semicolon. Float UI min equals negative 1.0 f, semicolon. Float UI max equals 1.0 f, semicolon. Float UI step equals 0.01 f, semicolon. Close greater than sign equals negative 0.4 f, semicolon. And then we're going to do float blur zoom here, open less than sign. String UI name equals, in quotes, blur zoom, close quotes, semicolon. String UI widget equals, in quotes, slider, close quotes, semicolon. Float UI min equals 0.0 f, semicolon. Float UI max equals 1.0 f, semicolon. Float UI step equals 0.01 f, semicolon. Close greater than symbol equals 1.0 f, semicolon. So that handles our blur zoom, and it's just like it sounds. I like to name things where they're straightforward for the artist. I should really throw a negative on that. Okay, when I'm applying this, it'd be a good idea to throw a negative on this so it's not like 1.0 is full, so that we go from 0 to 1, because that would make more sense to an artist than doing this way, because it kind of goes opposite way of what you would expect. Yeah. Okay. So wait, just in order to reverse that order of going from 0 to 1 there, if you want to reverse that, to throw a negative in there, and I'll take care of it. Or should anyways, logically speaking. I did that on another control and it worked fine. Okay, so float here, center X here, open less than sign here, string UI name equals, in quotes, center X axis, close quotes, semicolon. Actually, I think I did it on this one. And I think I must have undid the little fix I did for that. Okay. String UI widget equals, in quotes here, slider, close quotes, semicolon. Float UI min equals negative 1.0 f, semicolon. Float UI max equals 2.0 f, semicolon. Float UI step equals 0.01 f, semicolon. Close greater than symbol equals 0.5 f, semicolon. Okay, float center Y here. Now we have to find the center of the image here, so center of the model. Well, I mean, we can move the center too. So center where the radius for the radial blur occurs. Of course, 5.5 would be the center of the screen image for the radial blur. So makes sense to do that. But anyways. So you're probably going to want 0.5 like almost always. But yeah. Then you're going to see the effect at different angles and stuff. Alright. But float center here, Y equals greater than symbol, string UI name equals, in quotes here, center space Y space axis, close quotes, semicolon. String UI widget equals, in quotes here, slider, close quotes, semicolon. Float UI min equals negative 1.0 f, semicolon. Float UI max equals 2.0 f, semicolon. Float UI step equals 0.01 f, semicolon. Close greater than symbol equals 0.5 f, semicolon. Remember, f is for float, and this is well important to OpenGL. You have to put f with it to denote, if it's going to be an integer or a float or whatever. In this case, it's a float, so you can do an f. Float 4 here, clear color, open greater than symbol, string UI widget equals, in quotes, none, close quotes, semicolon. Close greater than sign equals curly brace 0, 0, 0, 0, 0, close curly brace, semicolon. So we're setting our clear color to be pure black, which is what it is right here. Works for me. Clear depth here, it's going to be 1.0 again, so float clear depth here. Open less than symbol, string UI widget equals, in quotes, none, close quotes, semicolon, greater than symbol equals 1.0, semicolon. So that's our depth. Over here to our texture, and this is different. Why is this different? Okay, something I want to point out to you. We are generating our images on the fly. Yes, we are actually creating our own images as the engine runs on the fly while we're actually looking at this. Check it out. Watch me move this. See how it moves on this image. Watch this image and watch what I'm doing on the screen over here. See how this look back and forth between the two. See how as I move one, it actually updates the other. That is because we are actually rendering this out as an actual image as we go here interactively. It's computing it very quickly per frame, and that's how this technique is being accomplished, and this is quite common of post effects. In the case of the depth here, here's our depth one here of 10, and so it's just pure white. There it is, 10, white, solid white, nothing. So where we multiply times it, we get ourselves. That's it. So if you're wondering how some of the stuff was working earlier, there you go. In the case of the pre-processing, of course, we're not outputting an image because we don't have anything to render. We're actually passing it an image that's already exists. In the case of a post, however, though, we are not. We are actually passing it something we have not yet. We are actually generating our own images. Sorry. We are rendering our objects first, and then in the post, after they've been rendered, after the scene has been rendered, we are then manipulating our image, our final image that we've rendered of our objects along with our pre-render. So that's the two laid on top of each other, composited together, whatever you have there. And then at this layer, at this level, we actually, at this point in the rendering process, we actually can manipulate the images, and that's exactly what we're doing here. And that's how we're getting this whole blur effect shooting off at all different directions. So that's what's happening right here. Texture here, screen space texture colon, render color target here, open less than sign here, float viewport ratio here equals curly brace here 1.0 comma 1.0 close curly brace semicolon. Alright, so this is our ratio that we're doing for our viewport. We do have an aspect ratio of 1.1 for this screen here, so we are doing a computer screen. If you look at your images here, you can actually see the resolution here, and it says, I'll have to leave my cursor here, but down here at the very bottom you see it says type color target here 298x 396 here 2D. That's this image here. That's the resolution and everything of that little screen down there. And that's our viewport, and it's calculating quite quickly. So FYI, pretty cool, huh? And it even tells you your format too a lot of times here if you click on it. So they'll give you the format. Yeah, so here's your format right here, as you can see, and here's our width and here's our height resolutions that was generated. This is generated, yeah. And that's what this render color target is about. So this is the render color target image, and it comes up as render color target when we click on it. It should say that somewhere. I don't know where. Oh, I'll call it screen space texture. Sorry, screen space texture. The render color target is what we're rendering to. I'm sorry. This is the diffuse channel, if you will. Okay. And then later on, we're going to do the render depth stencil target, which is our depth one right here, which is the white one, which we call depth buffer texture. But we'll get into that in a second. Int mip levels here equals 1 semicolon. So you can do mip map levels here. In this case, we only have one because we don't care. We just render it to the screen and we can composite it, so we don't need mip map levels. However, for generating an image that needs to have mip map levels for level of detail, this is where you could actually set how many levels you want to have mip mapping on, and then it will generate that image. So very cool. String format equals in quotes here A8, which is alpha 8-bit, R8, which is red 8-bit channel, G8, which is your green 8-bit channel, and then B8, which is your blue 8-bit channel, close quotes, semicolon. So we're doing RGBA, basically. Yes, I know it's out of order, but that's on purpose. It's supposed to be like that. Okay, just do it just like that. String UI name here equals, in quotes here, screen space texture, and that became the name of our texture over here. Well, in the UI interface, sorry. You'll see screen space texture appear right here. And then as far as the actual name goes, that's based on this right here, the image. A string UI widget equals quotes, close quotes, semicolon, so nothing in there, just leave it just like that. String resource type equals, in quotes, 2D, close quotes, semicolon. So that's important too. I think that's necessary. May not be, but put it in there to be safe. Oh yeah, I was playing around with this. Sorry. Like I said, I need to remove some stuff. Okay, yeah, so it wasn't necessary because I didn't use it down here, but put it in anyways. It's just extra info for it to know what format. Well, I guess, no, actually, technically, I don't have to worry about it, right? Because there's no resource, because we're generating it. Whatever. See, no change. Okay. I wasn't thinking, yeah, because I don't have a resource. I'm generating an image, so don't need it. Probably make it run a little faster by taking it out. Sampler 2D here, screen space sampler equals sampler underscore state. Open curly brace here, texture equals one less than symbol here, screen space texture, close greater than symbol, semicolon here, mag filter equals linear, semicolon, min filter equals linear, semicolon, mip filter equals point, semicolon, wrap s equals clamp to edge, semicolon, wrap t is equal to clamp to edge, semicolon, close curly brace, semicolon. There we go. And note this is wrap s here equals clamp to edge. This is important. Do not leave this out. This is very important. And so is this one right here. We need this in order to sample it because it's got to sample it from to the screen or whatever. The MIP filter is set to point. Make sure it's set to this. If you don't do this, I know we didn't use this stuff previously. You must put it in there. If you do not put this stuff in here, it will not work. Okay. Mag filter is now linear and min filter is linear. So it's not linear, map linear, it's just linear. Okay. So make sure you have that set just like that. Okay, so this is really important. This is very different than what we had previously. Like pretty much everything in this thing is different. So yeah, nothing stayed the same. All of it changed. Except of course maybe texture. But it has a different name in it, of course. But whatever. Texture here, depth buffer, texture colon, render depth stencil target. So render depth stencil target. Open less than symbol, and that's going to make it render to this channel here. So it goes to the stencil buffer. Special memory spot in the card, just like there's a special memory spot for your regular buffer for rendering, screen buffer. So, there's triple buffering, there's all kinds of stuff. I'm not going to get into it all. But yeah, there's several things you can use. Open lesson symbol here, float 2, viewport ratio equals curly brace here, 1.0, comma 1.0, close curly brace, semicolon here, string format equals, in quotes, D2 4 S8. So this should be the depth, should be 24, and I cannot remember what the S8 is. Can't remember. Close quotes, semicolon. UI, string UI name equals, in quotes, depth buffer texture, close quotes, semicolon. And then string UI widget equals, in quotes, close quotes, semicolon. But this is important. And this makes it, oh, dude, I'm not thinking. Yeah, this makes it a single channel for the alpha. So it's just black and white grayscale. That's what this is about. It's an 8-bit, single 8-bit channel here for doing your grayscale. That's it. For your depth buffer. I'm not thinking. That's what the S8 is. So, there you go. Close, see here, greater than symbol, semicolon here. Sampler 2D, depth buffer sampler equals sampler underscore state here. Open curly brace here. Texture equals open less than symbol, depth buffer texture, close greater than symbol, semicolon. Mag filter equals linear, semicolon. Min filter equals linear, semicolon. Mip filter equals point, semicolon. Wrap S equals clamp to edge, semicolon. Wrap T equals clamp to edge, semicolon. Close curly brace, semicolon. Alright. Again, this is very important. This is all very different than we'd done previously. Well, not up here. Of course, it's just like this up here. However, it's very different to what we used to do back when. So if you just copy and paste this one up here to down here, one thing you have to do is change that from screen space texture to def buffer texture here, and you're good to go. It's the same otherwise. I don't think we actually use a def buffer sampler, buffer sampler. So if you want, you can actually not even put it in. If I'm not mistaken, it's generated but never utilized. I mean, the image is generated but it's not sampled, if you will. Yeah. See, it works just fine. So technically, you don't really need the def buffer sampler. But you do need to generate the def buffer stencil target because it does use it. It's just not going to be sampled per pixel. So I can get away with that right there, doing that. See, works fine. Didn't break. We're still doing okay. Sorry, I'm like rewriting this as I do the video, as I take out extraneous stuff I don't need on both of these shaders. Oh man. Alright, so we have struct here VSN here, open parentheses, open curly brace, float 3 here, position colon, position semicolon, float 2 UV colon, text chord 0 semicolon, close curly brace semicolon, struct VS out, open curly brace here, float 4 position colon, position semicolon, float 2 UV colon, text chord 0 semicolon, curly brace semicolon, struct FS out, open curly brace, float 4 color, color semicolon, close curly brace semicolon, and then we get down here, and then I could probably go back and remove extraneous information I don't need. I don't know if I'm gonna bother though. I may not bother. I can't decide. Alright. VS out here, main VS, open parentheses, VS in, space, I in, capital, close parentheses, open curly brace, VS out, space out, semicolon, out dot position equals float 4, open parentheses, in dot position dot xyz comma 1, close parentheses, semicolon, out dot uv equals in dot uv dot xy, minus float 2, open parentheses, center x comma center y, close parentheses, semicolon, return out, semicolon, close curly brace. And there we go. And that sets us up so that way we have our center being subtracted from our UV space here, so we can determine our new center for our position point. As you can see what I mean by that. Of course, at 0.5 it's going to keep it centered. Pretty close to center right there. Same thing goes for Y. And now you can see the effect of it. You're literally just taking these multiple samples and you're blurring them together is what's happening. If I were to come up here to my num samples here real quick, sorry, I shouldn't do this while I'm going through this, but oh well, I'm just trying to show you. I could take this down lower, maybe like 8 would be ridiculous. Low. Yeah, so you can start seeing the different passes. If I go down to 4, you'll really see it. Yeah, see? So it's just the teapot repeated over and over again, faded out and blurred together, essentially. There's 16 again. I don't know, kind of got a good result with just 16 of them. Yeah, 16 of them seem to work pretty good. A lot of people use 16 in game. Okay. Yeah. Churn out. FS out, main PS, open parentheses, VS out, space, IN, caps here, close parentheses, open curly brace here, FS out, space, out, semicolon, 4, open parentheses, int, space, count here equals 0, semicolon, count here less than num samples, semicolon, count plus pluses. This is where we're going to iterate through our samples, adding them together. So we're going to do a float resize. And it's going to equal blur zoom. So remember blur zoom there. And then plus blur amount times, okay, so I did it on blur amount. That's where I multiplied in my -1. It looks like I could probably stand to do a little better by putting in our blur zoom here. And maybe I can reverse this from what I have currently by multiplying that like that. Let's see if I can't make it do what I want on that. Oh, no. Alright, it was a failed experiment, I guess. That was an idea, but a bad one. Alright. I'm not thinking about it right now. I'm trying to do it off the top of my... Well, I'm not even thinking when I'm recording anyways, hardly. Try one other method. Maybe if I do an inverse on it. I don't know. I might be, yeah. Oh, no. Okay. I'm not thinking about it right now. Correctly anyways, let's put it that way. And if I were to think about this for a bit, I'd probably knock it out in no time. But right now, I'm not going to think clearly because I'm making a video. It's just the wrong time to try this stuff out. Alright. So compile blur zoom plus blur amount here times -1.0 times, and I did this in order to flip around the blur amount so that way it's in a more straightforward manner. Because before, yeah, that's what I did. Because before you'd go negative and we could make it grow bigger, and when I went positive, make it shrink, which was counterintuitive to an artist. So what I did for that. So I did do this earlier on this one, just not the other one. It didn't work on the other one apparently either. So, so basically what I did for this one is just multiply it times -1, and that takes care of it. By doing that, it swaps my -1 with my 1, and my +1 with my -1, right? Because if you multiply it times -1, it'll go both ways. Thought maybe they would do that for me for my blur zoom, but no. No dice. No dice. Wait a minute, what if I just subtract 1? I really gotta stop this. I really gotta stop this. Right, that's what I would get. And then if I came down here... Okay, no, I gotta stop. I'm sorry. My apologies. This is something I need to play with off camera, off the video. It just occurred to me that that might be able to swap it around the other way. Just didn't expect to flip the teapot upside down. Okay, I just have to play with it. Okay. Anyhow, times count here in parentheses, divide by float here in parentheses, by parentheses number score samples minus 1.0 close parentheses semicolon. Okay, so what's happening here? We're dealing with the amount that we're going to zoom in, which right now is nothing at all for our zoom. And then here we're controlling our blur amount. How much those images are going to move, be scaled up more or less. And I call it blur amount because that's going to make sense to an artist, not necessarily that's accurate. So depending on which sample it would be on this case here, it's going to determine how big it's going to be here for our, how far out from the original teapot's position it's going to be scaled out. So here we have our count here divided by the float num samples here minus 1.0 here in order to determine, you know, how much it basically spreads out from the teapot. So there we go. That gives us our resizing or scaling of our images for our different samples here for each sample. And as we get each sample, see, it automatically stacks it up because as you increase in numbers here for your count here, it's going to be a different ratio here to your num samples. So therefore, it's going to stair step up all these different images, packing them on top of each other. But there's something we need to do after that. We need to add these together so they kind of like blur together. So we're going to do out.color here plus equals text 2D, your open parentheses, screen space sampler, which is what goes to here. Alright, and then in.uv.xy here times resize plus, so we're taking this thing here and we're saying, okay, with the UVs here, multiplied times resize plus our float 2 here for our center, based on our center point here, it's going to be determining our final color here. So each time we go through this loop, it's adding on another iteration here and adding the colors so they build on top of each other. That's why you get this glowish effect to it. So it's building, 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 building on here. Well, that's cool. Then we get down here and we say out.color here divided by num samples. We got 16 of them, so we're going to divide it by our num samples in order to get our overall color, so we don't get a ridiculously bright effect, right? Because we added it over here. So in order to reduce our amount of our add here, so we add it 16 times for our num samples currently. If we do 32, it'll be 32 times, right? So whatever we add on, it's going to be 32 times beyond what it should be for our color value, and everything needs to be blown out white. So instead, at the end, you divide it by num samples. Let me show you. See? It's overblown white here. Why is that? Because we need to have, because that's just 16 different values slapped on top of each other. And quite frankly, eventually, that is going to just completely overblow the pixels, no matter what color it is. It's just going to get so overblown, it's not funny. It's going to become like pure, solid, overblown white. So divide it by the number of samples to get it back to its original color. Bang, there you go. And that's why it's going on there. So that's why we're taking the color and dividing it by num samples here and assigning it back, of course, to our color. And we turn out from our color and we get this effect here. Alright, so let's look at our techniques now. Close curly brace, of course. And so you get some idea of what's happening here. Okay. Now mind you, this is going to our screen for our final render here. We're manipulating this after it's been rendered. So this is not, we're not talking about UV space for the actual teapot, but rather the screen quad. Don't forget there's a quad that we're rendering this to on the screen. So that's what we're messing with, not the actual teapot itself. That's confusing because you're like, oh, I see lots of teapots. You know, I see a teapot here. No, we're not doing the teapot model. We're doing the actual finalized rendered image that we got from the teapot, and then we are manipulating it on our screen space quad here. So that's what's happening. So technique 0, open lesson sign string script equals, and then pound sign here, if not defined, shared underscore bg underscore image here, render color target 0 equals screen space texture semicolon close quotes. All right, so we're setting it to our render target for our first color render target to be our screen space texture. Yay. And then we say render depth stencil target equals depth buffer texture. So we're going to make it go to this texture for being processed when we're doing our shared background image. And then we do clear set color equals clear color semicolon close quotes. Clear set depth equals clear depth semicolon close quotes. Then we're going to clear color, we're going to clear depth. And of course this makes sense. We've been doing this for a while, so same thing there. Script external equals color, of course we're doing color, semicolon, close quotes around this, and then pass equals P0 semicolon, because that's what we have for our pass down here, close quotes. Else, defined, so if it's not defined as, so if it is defined, sorry, if not defined as shared, if it is defined as a shared background image, then we're going to do this here. We're going to say clear set color equals clear color semicolon in quotes. Clear set depth here equals clear depth semicolon close quotes. Clear equals color semicolon. Clear equals depth semicolon. Pass equals P0 semicolon. And there you go. And that's pretty cool right there for getting this set up. Okay, so again, if it's not a shared image, sorry, background image, then we're going to create our images here. If it is, then we don't have to worry about creating these. Okay, in the case here, it's already been processed, so it's up there, so we don't keep processing it over and over again if the camera doesn't move. If the camera does move, then we need to update it, blah, blah, blah. Pound sign if here, shared underscore bg underscore image. All right, close greater than symbol. open curly brace here, pass here, space P0 here, open less than sign, string script equals here, quotes here, render color target 0 equals semicolon, close quotes here, open quotes here, render depth stencil target equals semicolon, close quotes, open quotes, draw equals buffer, semicolon, close quotes, semicolon, close greater than symbol, open curly brace here, and of course draw buffer because we're going to draw to the buffer. Open curly brace here, depth test enable equals false, semicolon, depth mask equals false, semicolon, cold face enable equals false, semicolon, blend enable equals false, semicolon, depth func equals L equal, semicolon, vertex programs equals compile VP40 main VS, open close parentheses, semicolon, fragment program equals compile FP40 main PS, open close parentheses, semicolon, close parentheses, close curly brace, and that's the end of our radial blur screen space effect. So I hope this was a pretty cool effect. I think it is anyways. It's used in a lot of games. It's pretty awesome. It's very popular in a lot of games, and I think you're starting to see some of the coolest, more cool effects that we have and everything in here as we start to move through this more and more. In the next video, we're going to do God rays, and I'm going to write another screen space shader. I thought I had 8, but I have 7. So I'm going to have to write one more. I'm not sure which one I'm going to write yet, but we'll look at it and see what we can't do about that. Real quick though, let me just middle click over here again. And I'm just going to hit Control Z here and do some of my craziness. This is why you don't want to play around with this stuff too much before you start undoing to get rid of that screen space effect. Yeah, I really shouldn't have played around those values while I was recording. My apologies. You can kind of see what's happening though. I'm going to show it to you in a second here. I'm flying through the undos. It's like holding down the Control Z and not even like toggling through it. Yeah, unfortunately, when you move that slider around, it's actually sampling. Every one of those is an undo. So it's just a lot to undo, I'm afraid. It's probably went through thousands of undos already just by holding this thing down like this. I don't want to go too far, you know. You'll have to get the art of undo here. There it is. Without removing your own shader in the process, right? It's very easy to do, let me tell you. Alrighty. Alright, and then I'll show you God rays, which we're going to do in the next video, which is really cool. Okay. So it's a lot like radial blur, but it actually glows and has intensity and breaks across the surface. Here's the model that you're shooting around it. So you get these rays of light that are shooting across it. So you can see where it's based off of radial blur. But it's very cool. I'm just going to go ahead and increase this back up, I guess. No, maybe down more. Can never decide, huh? You can also turn up your intensity on this thing, depending on how much you want to go or how little you want to go on it. So it's got some extra controls in it. It's got blur mount, it's got the zoom, all that fun stuff along with the center part and everything. It's a lot like what we did, but we're going to add something there. And God rays is pretty popular. That's where you have those shafts of light coming through, and this is how you make it. And yeah, I did just add it to Unity no more than like months ago, I think. from here. But yeah, it's a pretty cool effect. And with that, that covers. We're going to do that one next, and then we're going to do some other ones. I don't know, we may do glow or something like that. I'm not sure yet. I might do, I'm not sure. I'll look back at. I got several different glows I could choose from, so I just don't know which one I want to do. I don't know, I might do cross-shaped or circular. Circular bloom's nice too. I like both of them. We may do both, I don't know. But anyways, with that, that covers screen space shooting with radial blur, and also the pass-through. My name is Nate Nestler. This is for Hyperactive Studios. Thank you very much.